Hello, good morning. How are you doing? Nice to see you here. Today is the 24th of December, which means it's also the day 24 of Advent of Code. We've arrived at the second last day of the event. Yeah, let's do this. Yesterday, we were busy with day 23. We managed to solve the first part. The second part, I was a little bit stuck there. The second part involved significantly more cups and moves, which made the solution from part one run far too long. I think it took about 1 hour and a half to solve, according to my estimation, to come with an answer. So it had to be optimized. I was trying to look for a pattern, and there wasn't none. So I eventually left that approach. And I later figured out that a best way to solve this would be using a linked list, which is a more efficient way than using an array for this problem, because a linked list would not take up so much time whenever you took out 3 cups from the labels, from all the cups, and inserted them somewhere else. That's much faster in a linked list than an array, because an array needs to resort all the numbers, shift them by 3, and then when you put them back, it needs to shift all the other cups as well. So that was much more CPU intensive, which is why it took so long. I didn't get time to finish that, but I will. I'll post a solution in my in the repository, which I link to in the chat, and or if you're watching this on YouTube, it's going to be in the description. So keep an eye on that. I'll solve that later. Without further ado, let's get on to day 24. If you're watching, let me know how you're doing, and say hi. Yep. Today's puzzle is about lobby layout. Your raft makes it to the tropical island. It turns out that the small crab was an excellent navigator. You make your way to the resort. As you enter the lobby, ooh, we finally made it to the resort. That's awesome. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they finished installing the new tile floor. The tiles are all hexagonal. Hexagonal, is that how you pronounce it? Hexagonal? No, hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. A member of the renovation crew gives you a list of the tiles that need to be flipped over, which is the puzzle input for today. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps, starting from a reference tile in the very center of the room. Every line starts from the same reference tile. Alright. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. These directions are given in your list, respectively as E, SE, SW, W, NW, and E. A tile is identified by a series of these directions with no delimiters. For example, E, S, E, and EE identifies the tile you land on if you start at the reference tile and then move one tile east, one tile southeast, one tile northeast, and one tile east. The fact that this does not have any delimiters is going to make it a little bit tricky to parse. Each time a tile is identified, it flips from white to black, or from black to white. Tiles might be flipped more than once. For example, a line like this one flips a tile immediately adjacent to the reference tile, and a line like this one flips the reference tile itself. That's interesting. So let me reread this again. A tile is identified by a series of directions. Alright, so this identifies the tile you land on if you start at the reference tile and then move, and each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. For example, a line like, so this is east, southeast, and west, I guess, flips a tile immediately adjacent to the reference tile. Because it goes east and then southeast and then west, right? So it goes back. And the line like flips the reference tile itself, because this is northwest, northwest, and then we go west and then southwest, not that way, and then well, this might be southwest, EE. What is EE? Is EE something? No, not really. So this must be south, and this must be, oh, that's interesting. What is this? This must be northwest and W, and then W must be west, and then we have SW, which is southwest, and then east. Oh, east could be twice, right? Go back east twice. So here's a larger example. This is the input. In the above example, 10 tiles are flipped once to black, and 5 more are flipped twice to black, then black to white. After all of these instructions have been followed, a total of 10 tiles are black. Interesting. Go through the renovation screw list and determine which tiles they need to flip. After all of the instructions have been followed, how many tiles are left with the black side up? So let's see. All tiles are all white on one side and black on the other. They start with the white side facing up. Alright, so all tiles are white. And then we need to flip some tiles depending on the puzzle input. They need to be flipped over. And they're hexagonal. Okay. So something I don't understand, I'm trying to figure out, is that for example, this line flips the tile immediately adjacent to the reference tile, and the line like this line flips the reference tile itself. Alright, so larger example. In the above example, 10 tiles are flipped once to black. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 8, 6, 7, 8, 9, 10. So it's 20. So 10 tiles are flipped once, and 5 more tiles are flipped twice, because, alright, so there's 5 of these tiles kind of like appear twice. 2 instructions lead to the same tile, which make it flip twice. Okay. All right, I do understand that. Let's get our puzzle input. Significantly longer. Let's save this into our working directory. Ooh, today's going to be interesting because we are dealing with a hexagonal grid, and what is the answer for part 1? How many cells are left with the black side up? So I guess we need to keep track of how many we flipped up once, or 3 times, or 5 times, uneven times, because even times are going to go back to white, so we can discard those. So a way to solve this would be to like well, first we need to figure out the parsing, which is quite tricky because it's not delimited if we separate this by nothing. So by just like whatever it is. So let's try and input split. We're gonna get new lines. So we split by new line, and then each line is gonna be map. What do they call this? Instruction or like directions. Let's see. Directions, right? So direction split. If I just split it like this, and I just say this is directions, let's add a breakpoint here. These are the expressions from yesterday. So then we're gonna end up with 487 directions, and each direction is like this. And how do I know? I need to figure out, how do I know whether something is west? So for example, this direction, whether this is west or northwest. How do I know that? That's interesting. So let's read. So there's so the directions can be east, southeast, southwest, west, northwest, northeast. How about south? Well, that's interesting. There's no south. Wait, I'm a bit. Let's look at how is it really placed. So we have north, south, and then we have northeast, southeast, northwest, southwest. Is that it? What did they say here? Where is it here? East, southeast, southwest, west, northwest. Oh, so yeah, it's rotated. It's rotated, so it's not like this. It's can we find a hexagonal grid that is rotated somewhere in these examples? Not really. So it's kind of like rotated instead of, if you look at this one, and if you turn it around and say this is north and this is south, then we have north, west, and northeast, west and east, and then we have south, west, and southeast. I think that's what's going on. Let's see. We have east and west, and then we have southeast, southwest, and northwest, northeast. All right, yeah, that makes sense. Which means that there is no north and there is no south. So knowing that, we know that this is west, 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 this is northwest. Okay, that'll make the parsing definitely easier. Definitely easier. In that case, we can assume that whenever we find an S or an N, it'll be followed by either an E or W, making it east or west. Right. So let's do the parsing there then. I'm gonna add these two. Might have noticed the music has changed today. It's a little bit lo-fi. It's supposed to be a Christmas playlist. I might change it a bit later if I think it's too low, and if I prefer something more upbeat. All right, so we have the direction, split it, but let's actually, yeah, we need so we split it in here, and then we're gonna need to loop over it. We can use a reduce to do that. And then that's going to be an array, I guess. And then we're going to have our accumulator, and then we're going to have our let me rename this variable to something more, because so these is what's our puzzle input? List of tiles that need to be flipped over. So then let's call this a tiles list, and then we'll call this directions for a tile directions, just directions, and then this one is going to be direction, so it's going to be a single direction. And then if direction is either east or west, includes direction, then we're gonna say accumulator push direction. Else we know it's east and west. Can I somehow get the next element with reduce, or will I have to tap into the array? Does reduce give us the next element? It should, right? Current value? No, it doesn't. But it somehow... What's the best way to do this? Maybe not using a reduce, but a just iterating over and changing that. Or I could use regex. Would regex help me a little bit? Let's look at the inputs. I could use a regex, I guess, perhaps. I'm gonna try and see if I can come up with a quick regex to parse this. So I need to grab E. It's gonna be yep, and or northeast. East or west, or northeast or northwest, or southeast, southwest, and then it needs to be, I think it's greedy by default, isn't it? So what are the matches that we get here? We get west, 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 northwest, west, 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 east, northwest. Yeah, this works. Let's add a couple more. Where did I take it from? Here. Let's add a couple more. All right, this seems to work. So I guess we're gonna get an array, or like let's try and see what this gives us. Spin upon JS. So we have this input, and we're gonna say match. And where's our regex? Here. And let's add a global modifier. Yeah, so we kind of like get an array of all of those, and it looks good. We have only northeast. We don't have any north or south because they don't exist. All right, I'm gonna use this regex. That wasn't too hard. I was expecting a more difficult regex. Then I can just say I can actually get rid of all of this, and I can do it in one line. I can say directions match that regex, and so therefore let's run again. We're looking at the tiles list, right? Okay, so this seems good. Yep, we have our directions parsed in here: southwest, west, southwest, southeast. Great. So we have our tiles list in here. So that's one thing out of the way. And then for each tile, we'll go through them, and then we need to figure out which tile kind of like we arrived at and flip it. So I'm thinking a tile would have a coordinate, right? Each tile kind of like has a coordinate, and maybe I can calculate the coordinate of every tile and keep track of what it's been flipped once, and then as I go through each line I'll get a new coordinate, and if that's the same coordinate we found before, we flip it again, kind of like that. That's something I'm thinking of. But how does a hexagonal coordinate look like? So I have to do a little bit of Googling. I haven't worked much with hexagonal grids and programming. Hexagonal coordinate system. Right. So yeah, this is exactly how a hexagonal looks like, because we have west, east, and then we have northwest, northeast, southeast, southwest. And then let's see what this Stack Overflow answer says. Offsets. Cube coordinates. Oh yeah, you can have cube coordinates as well. This looks like a bit like Soldiers of Catan. Is this Soldiers of Catan or is it Travelers of Catan? I don't know. Catan game. It's really cool. So, and we have axial coordinates. Okay, let's see what. So offset coordinates. The most common approach is to offset every other column or row. Columns are named col or q. Rows are named row or r. You can either offset the odd or the even columns. So the horizontal and vertical hexagons each have two variants. All right. So this one starts at 0, 0, and then you go 1, 0, 2, 0, right, and then you go there 0, 1, and then 1, and then 0, 1, 0, 2, kind of like this. Okay. This is pretty straightforward. This makes sense because you still have a 2D grid, and then you have the x-axis. So you increment the first value by 1 as you go to the right, and as you go south, you increment the column, the second value. But here, like going south east, you do go to the right a little bit, but you don't increment x yet, only after you've gone a second time. So that's something that we'll need to keep track of in the program if we want to use this coordinate system. Let me have a look at the other two, see what's easiest to implement. Another way to look at hexagonal grids is to see that there are 3 primary axes, unlike the 2 we have for square grids. There's an elegant symmetry with these. So we start, where are we starting here? Here. Also, you have 3 axes, x, y, and z, and then going to the right is I think this is kind of like a 3D, makes it a 3D coordinate. So you move to the right by x1, and then y is -1 and z stays the same. So this is the z plane, and what's the x plane? This is the x plane. Oh no, wait, this is the z plane. Oh yes, the same. This is the x-axis, this is the y-axis, because they're all -1. Here they're all 0, and here they're all 1. That seems easier to implement in program, because you don't need to keep track of whether you're like a half x or half y in either direction. Whenever you starting from the origin, let's say this is the origin, whenever you go either direction, one of the axes is going to change. So if you start at, this is kind of a bit confusing because they start at different numbers, but let's say, right, so here you start at x is 0 and you go to the right, to the west, then you're gonna increment x by 1. Or if you go northwest, so x is incremented by 1 in the east and northeast direction, and decrements by 1 in the west and southwest direction, and it stays the same in the north, west, and southeast. Okay, I might implement this one. Let me have a look at the last one. How does this one look like? So you start at 0, 0. Actual coordinate system, something called trapezoidal, is built by taking 2 of the 3 coordinates from cube coordinate system. Right. From abstract for like cube coordinates, you can use the standard as subtract. Interesting. I'm gonna stick with cube coordinates. I think that will do, and I'll just so I'll have to loop through each tile. So I'll go, let me remove this breakpoint. 4 const directions of tiles list, and then let me keep track of, well, not here, I'm gonna say let x, let y, and let z, and then we'll say 4 const direction of directions. We're going to have to adjust the current coordinate. So let's start these at 0, and we'll do all the rules in there, and then as soon as when we applied all the direction, we found a tile, so we can store the x, y, and z coordinates for that tile somewhere. What's the best thing to do? So we're gonna have a tile, we store x, y, and z. We could store in an object with the x, with the coordinates being the being the key, object key, and the value would be how many times we flipped it. Is that something sensible? The best approach would be something that would fit for the second part as well. And usually the second part has a twist, which makes it either straightforward depending on or difficult depending on your the way you solve the first part. So I'm thinking in a previous day, I think it was day 20 or so, 21, I had an approach for the first part that completely did not work for the second part, and it was also with building a map. And I was being clever, I did not build a map at all, and then the second part required me to build a map, so I had to start from scratch. So maybe here the second part is gonna ask us to maybe there's gonna be a shape on the floor or something that we need to, so therefore we'll see. I think I'm gonna stick with this approach. I'm gonna have an object with the coordinates, and I'm gonna have the values, the number of times we found that object. So let's say let's have the object called, what do we call it? Tiles list, just tiles, I guess. The keys are gonna be the tile coordinates, and really bad at naming. Because we're gonna have, for example, we're gonna have something like this. We're gonna have x, 1, y might be 3. We can separate it by comma to make it easier, and c might be 9, and then it's gonna be 1, something like this. So what do we call this? This is a tile coordinate, and this is the number of times we flip that tile. Let's call it tile flips. That's something that makes sense to me. Tile flips. All right. So tile flips is gonna be x, and the value of x, comma y, and then the value of y, and z, and then the value of z, and it's going to be equal to, well, if it doesn't exist yet, it's going to be 1, otherwise we need to increment it. So we can say or I can do a nullish coalescing and say it's 0, and then duplicate this and have it plus plus. So this is the nullish coalescing operator, which means, let me look it up, what it does. Which means it's going to assignment. It's assignment, not operator. So it's the nullish assignment operator, which only assigns if x is nullish, which means it's null or undefined. In our case, it's going to be undefined. So this line only executes if this one is undefined, in which case we're going to assign it to 0. Meaning that the first time we find the tile, it's not going to be in our object, so we set it to 0 and then we increment it by 1. If we already found the tile, this is not gonna do anything. So then the tile might be already 1 or 2, whatever times we found it before. So then we're just gonna increment it by 1. So that's what's happening here. And then let's figure out the navigation. Here it is, cube coordinates. So I guess you could say if includes direction. So if we're going east or northeast, then x plus plus. So if you're going east or northeast, we're going to increment x. If we're going what's easiest to do? I guess the easiest is to do by direction, right? Because now I'm going to yeah, I think the easiest is to approach this by direction. So let's just do it like this. I'm gonna start clockwise from east. So if direction is equal to east, then we're gonna do something. Else, if direction equals southeast, we're gonna do something else. So let's copy this southeast, southwest, west, northwest, northeast, and then we're back to east. So we have 6 of them. Yeah. And let's change this to southwest. Well, southwest, west, northwest, northeast, and all right. So if you're going east, we are incrementing x by 1, and we are decrementing y. So x plus plus, y minus minus. Okay, so we're gonna do the same thing for everything else. South, so we're going southeast. We increment z and decrement y. And then let me just move the cursor here. Okay, so southwest, we decrement x and increment c. Decrement x, increment c. Let me make sure I did that correctly. Decrement x and increment c. That's correct. So we're going west then, and we decrement x, and we decrement. Let me see. We decrement x and we increment y. Right, and then northwest is. Northwest, we increment y and increment z as well. Y plus plus, z plus plus, and the last one, northeast, is we increment x and decrement z. Increment x, decrement c. Hopefully this is right. We're going east, we increment. They should be opposites. So east and west are opposites. So incrementing x, incrementing y, decrementing y. Okay. Southeast and northwest should be opposites. So incrementing z. Let's see. Southeast, we increment c. All right, we made a typo here, and northwest should be decrementing z. Okay, and then decrement y, and therefore we should be incrementing y. Okay, and then southwest and northeast are opposites as well. So we decrement x here and increment it here, and we increment z and decrement z here. Okay, that looks, I think, correct. so far. There might be a bug in here, but we'll figure that out later. And here is directions. Good. All right, let's run the program and see what happens. I'm gonna grab the example input they gave us here, because I'm gonna use that to kind of like test and debug. Put it over here, and we're gonna run it with input 2, and I'm gonna add a console log here just for debugging purposes, so I can add a breakpoint to that line, and then I'm gonna run the program. And let's see what the tile flips looks like. So we have a bunch of tiles. So the answer for the example input was that in the above example, 10 tiles are flipped once and 5 tiles are flipped twice. Let's see if that's correct. So we should have 5 of 2s. So 1, 2, 3, 4, 5. That's good. And we should have 10 of 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. So then the answer is a total of 10 tiles are black. Okay, so we need to filter out those tiles that have an odd number, because tiles that have an even number of flips have been flipped back to their original white state. So we need only those tiles that have been flipped an odd number of times. Then those tiles are black, and then we have the answer for part 1. So let's say const number of black tiles, and then we say object values tile flips, and then we're gonna filter any values of this is gonna be flips. Flips is an odd number. I think I can use the modulo for that. Modulo 2 equals 0. This is gonna be equal flips, and so it needs to not be equal to 0. Then we're gonna have odd flips, and so we filter those out, and I guess we can do length to get the number of tiles. So our answer for part 1 is gonna be answer part 1 number of black tiles. Right, let's run the program. Day 24 index.js 10 tiles. That's correct. Okay, I feel pretty good about this. Let's run it with our own input and see what the final answer is. Interesting, we get an error. Directions is not iterable. Oh, I know probably why, because I forgot to remove the last new line. Yeah, this is going to be an element as well, so we want to get rid of that. All right, so we get 420 tiles. Let's try this answer. Correct, we solved the first part. That's awesome. That wasn't too hard, but I'm suspecting part 2 is going to be significantly more difficult. So let's get to it. Part 2, the tile floor in the lobby is meant to be a living art exhibit. Every day the tiles are all flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. So we've had this 2 more times, 2 times in Advent of Code previous days, is that this looks a bit like Conway's Game of Life. but now we have a hexagonal grid, so that's going to be interesting. Here, tiles immediately adjacent means the 6 tiles directly touching the tile in question. The rules are applied simultaneously to every tile. Put another way, it is first determined which tiles need to be flipped, and they're all flipped at the same time. In the above example, the number of black tiles that are facing up after the given number of days has passed is as follows. Day 1, 2, days 100. Okay, after executing this process a total of 100 times, there would be 2,208 black tiles facing up. How many tiles would be black after 100 days? Alright, so the second part is a spin, Conway's Game of Life spin to this problem. And we need to go through all our tiles and figure out whether they should be flipped or not according to these two rules, and we're going to do that 100 times. So we're going to have a while loop in here. Let day 1, I'm going to start with day 1, while day is smaller or equal than 100, we're going to do this 100 days, and at the end we're going to increment day. We're going to go to the next day. So 100 days we're going to need to flip certain tiles, and I think our approach from the first part is going to serve us well here, because we have the coordinates. We have the coordinates of each tile, which makes it easier to find out the neighbors, because here we're going to need to find out the 6 neighbors for each tile. So the rules is any white tile, so all tiles start with white, with exactly 2 black tiles immediately adjacent to it. Is flipped to black, otherwise it stays white, I guess. And any black tile with 0 or more than 2 black tiles, so 0 or more, is flipped to white. So 0 or more than 2 is flipped to white. So if it has 1 black neighbor or 2 black tile neighbor, then it stays black. Alright. The only thing is that let's see how big our grid is. The grid is infinite, but given our input, how big is that grid? So we have tiles list. No, we need tile flips. So we have 400 something tiles, 486 tiles. Our grid is relatively big, I guess. I go 16, 17 in a Z minus, like within 20, 20, 20. Yeah, I don't see any coordinate going outside of 20, but that of course can expand. And also, not all the tiles in the grid that we need to consider are in our object, because there's also going to be neighboring tiles that we haven't flipped, but we need to consider because they might have black tiles as neighbors, so their state will change. So we need to consider all those tiles. And I can see curiously that the object's keys are sorted. So you can see that they're sorted by the X coordinate here. So we start, so X0. That's interesting. Okay. Thinking this is in the previous day. There was a similar problem where you had the Conway's Game of Life or so, and there was a cubed, there was a 3D world, 3D grid that you had to change, and it also had X, Y, and Z coordinates. and finding out the neighbors was kind of like that. So the solution for this, or at least finding the neighbors, is going to be pretty similar. I'm going to try and code that again without copy pasting, but in case I don't remember or want to refer to it, it's okay. I'm going to go back to that day and see if the code is right, because I managed to solve that day at the first part at least. The second part was 4D grid, which was more difficult. I think I solved that one too, but yeah, that was tricky. So what are we gonna do? We're gonna go through each tile. We're gonna have to iterate. We're gonna iterate through the X, Y, and Z planes. And we're gonna need to grab, I guess we're gonna need to grab the boundaries of those planes, so we know how far we need to iterate. And so let's do that. Let's say const min z or min x. We're gonna start with x. It's gonna be math min, and then we're gonna say object keys, tile flips, object keys, and then I'm gonna put this in a new line because most likely I will assign it to a variable. So we have all the keys here, and then for each keys we're gonna map tile coordinates. We're gonna split it by a comma. Alright, so then we have the X, Y, and Z in an array. And then we need the all the first values. So I already know what I'm going to assign it to. I'm going to assign it to X coordinates. And then I'm going to do another map to return the first value. X coordinate, and I'm gonna return a number that's gonna be X coordinate split, because I know every X coordinate is gonna start with an X and then it's gonna be whatever value. So it's a string, so I could use I just want to use grab the string from the, I can use substring, I guess. Returns a portion of the string. Length optional. Start. I guess I can use substring. And then we're gonna start at 1, I think. Starting the index of the first character to include in the return substring. Yep. Start at 1, and that's going to be a number, typecast to a number. I think this looks pretty good. Let's add a breakpoint here and see what the X coordinates are. Alright, that works. We have a bunch of X coordinates, and I'm assuming they're not unique. So let's make them unique by Well, do they have to be unique? They don't really have to be unique. I just need to grab the lowest x coordinates. So I'm going to spread the array into the math min, and I'm going to do the same for max, but I'm going to use max instead. So let's add a breakpoint here and see what. Right, there we have it. So our lowest x coordinate is -18 and our highest is 18. So we need to do the same thing for y and z. Const y coordinates. I'll just, I guess I'll just copy this. Copy everything, in fact. And just change the names. We're repeating the same code here, which is not very performant, but I'll keep it like that for now. Okay, so we have the y coordinate, and here the y coordinate is going to be the second element of that array, so that's why I added a comma. And then let's do the same thing for z. And then another comma in there, and then we have a z. It's going to be the third. All right, so we have our x, y, and z boundaries. So what we need to do is we need to iterate through those boundaries. But something I'm thinking of something that I know from previous days is that I'll need to expand the boundary by 1. Because this is the boundary where we have flip tiles, and they could be black. Therefore, the black tile might have an effect of what the white tile in an outside of it might do. So we have to expand each boundary by 1 in both directions. So maybe we can do that in a smart way where we'll loop. So let's do that. I'm gonna start with the z plane first. Const first we'll need an array to loop through, I guess. Or we don't need an array. We need const z is -c -1, and then this is going to have to be let, and then until z is smaller than, so while z is smaller or equal than max c, and then c++. So let me see, -c is going to be, let's say it's -18, so we're going to start at -19, and then we're going to keep going until max c is +1, smaller or equal than +1. Yeah, so with the -1 and the +1 in here, we kind of like expanded our boundaries by 1, so that's neat. We're gonna have another nested loop here for the y coordinates. And another one for x. right? So inside of here, we need to get, we're gonna get a hex, and we need to get its neighbors. And its neighbors are gonna be in both the Y and the Z planes. So what we can do is, it's gonna be 6 neighbors, so I could just have them in here. Let me think. The neighbor is gonna have to be in an array, because what I ultimately care about, I care about how many of those neighbors are either black or white. So I'm gonna put those neighbors in an array. So I'm gonna say const neighbors. It's gonna be an array, and then we're gonna have the first neighbor is gonna be, so that's where we're gonna use tile flips in here. Tile flips. Or if we don't find a tile, then we can assume it's been flipped 0 times, therefore it's white. And I'm gonna duplicate this for 6 tiles, all 6 neighbors. So 1, 2, 3, 4, 5, 6. And it's gonna have to be X something, Y something, and Z something, and these separated by comma. Okay, so perhaps I could better duplicate these. 1, 2, 3, 4, 5, 6. All right. So we're gonna start with the. So we're grabbing the neighbors now. So we have, let's say this is our tile that we're looking at. We're gonna have 6 neighbors. So again, starting with east, the neighbor east is gonna be at Y at Y minus 1, and X plus 1, and Z is going to be the same. So this is going to be Z, Y is going to be, oh, so X is plus 1, X plus 1, and Y is Y minus 1. So then I can add a comment east, and this is going to be southeast, and southeast neighbor is going to be X, it's going to be the same, Y is going to be minus 1, Y minus 1, and Z is going to be plus 1. So that's southeast. This one is going to be southwest. So southwest, we are X the same. Oh no, this is X. So X is minus 1. I need to make sure I don't make any mistakes here, because it's easy to make a mistake and it's going to lead to a completely wrong answer. Y is the same. So Y is the same, and Z is plus 1, and then we are west. West is minus 1 for X, Y is plus 1, and Z is the same. Then we have northwest, second last neighbor. X is going to be the same, Y is going to be plus 1, and z is going to be -1. And then the last one is northeast. And then x is +1, y is the same, and z is -1. All right, let's double check this is correct. So east and west are opposites. Therefore, x +1, x -1, y -1, y +2, z stays the same. Southeast and northwest are opposites. So southeast, x stay the same, x -1, y -1, y +1, z +1, z -1. That's correct. And these two are opposites as well. X -1, x +1, y stays the same, z +1, z -1. Looks good. So we have our neighbors in here, and we're gonna have to we're gonna filter the number of black neighbors. I guess that's what we care about, right? Because both rules care about black tiles. So we're gonna say const number of black neighbors, black tile neighbors, black tile neighbors, and then we say neighbors. I guess we can filter. Yep, and it's gonna be neighbor. And then same thing as above, modulo 2 is not equal to 0. Then we know it's an uneven number, which means it's an odd number, I mean. And odd and uneven are the same, aren't they? Yeah. And therefore, it must be a black tile. And then length. Forgot a parentheses here. Oh wait. Yeah, so there's going to be a number of black tiles. And let's implement our rules. So any black tile with 0 or more than, right, so black tile, so if current tile, let's grab a current tile here. Current tile is tile flips x, x, y, y, z, z, z. Right, so if current tile is black, meaning is modulo 2 not equal to 0, then and if current tile is black and 0 or more than 2 black tiles immediately adjacent to it is flipped to white. So number of black tile neighbors are either 0 or more than 2. So we can say is 0 or more than 2. Then the current tile is going to be flipped to white. So we can like say we add 1 to it. What I want to do is I don't want to modify the object in place because that's going to affect the other tiles on the next iteration. Because like they said in the puzzle, they are simultaneously flipped. So put it another way, it is first determined which tiles need to be flipped, then they're all flipped at the same time. So I can either keep track of which tiles need to be flipped and do that at the end, or I can create a copy of this object and then modify that copy and use that copy for the next iteration, and so on. So what's best here? I'm I'm gonna try and flip them all at the end. So I'm gonna keep an array. I'm gonna keep an array here of tiles to flip. And I'm gonna push coordinates of those tiles to that array. So I'm gonna push I'm gonna push on, I guess, this. Yep. And then so this is one condition, and I'm gonna name this condition black tile with const is black tile to be flipped, and all of this is kind of like what we're trying to assess here. So is black tile to be flipped, or is white tile to be flipped? Then we push that. So let's add another one here. Is white tile to be flipped, where current tile is obviously white, so this is going to be equal to 0. And so what's the rule for white? Exactly 2. If there's exactly 2, so and number of black tile neighbors is equal to 2, and therefore we should flip it. So then at the end, when we figure out all the tiles that need to be flipped, we're gonna go through each of the tile to flip, of tiles to flip, tiles to flip, and we're gonna say tile flips, tile to flip is plus plus. So this flip tiles. All right. Let's just run the program. Oh, and then at the end, we kind of do the same thing. We count the number of black tiles, I guess, right? Yeah. Same thing. Number of black tiles as a part 2. Something that I want to do is part 1 and part 2 are going to collide with each other, both in terms of variable names and the and this object, because using the same object in 2 parts, and I want to avoid that. So what I'm gonna do is, the parsing is good. I'm gonna move this to the top, and tile flips. Well, that doesn't really matter, no, because I'm reusing this, but I guess what's our starting input? So live in art exhibit. Every day the tiles are all flipped according to the following rules. After 1 day is 15. Okay, I think I understand. I think our starting tiles are the same, the tiles from the results from part 1, isn't it? If I'm not mistaken. Let's run it with the example input after they... Yeah, let's run it with the example input. But what I'm gonna do is I'm gonna move this up top. I'm gonna have an immediately executing function invocation to scope everything inside part 2. I'm gonna put entire part 2 in there, part 1 I mean, so that we don't have any variable name collisions. I'm gonna do the same for part 2. And then I'm gonna run the program with the example input, input number 2, and see what the end result is like for part 2. First, let's fix some bugs or some errors. Push is not a function. Tile flips push, of course, because it's tiles to flip. All right. It takes a little while. Hopefully not too long. Maximum call stack exceeded. Size exceeded. Huh, that's interesting. Oh, I see. No, we're modifying the object in place, so then on the next iteration we should get new coordinates. I could be a bit more efficient about this and this is repeating. I could do this once instead of 3 times. I'm not sure where this line 55, it's coming from here, column 23, math min. I guess it's too many coordinates, is that why? Let me add a breakpoint here and see day 2, day 3, day 4, 5, 6. I guess by the end kind of like becomes day 13, 14. So around day 22, it takes a bit longer here. Yeah, I could be more efficient about this and only do this once. So let's do that. What do we call these? Object keys, tiles flip, tile coordinates split. I can call this tile coordinates or just coordinates. And paste this in here. And then that's going to be coordinates map. All right, so I can remove all of this and just say coordinates map. Yeah, so we don't repeat the same thing every time. Maybe this is gonna prevent us from exceeding the stack size. No? Nope. So it's happening at math min. I guess I could add a conditional breakpoint when day modulo not modulo in days bigger than 50 or 60. Let's try that. So we are day 60 now, or day 61. No, it quit, so it doesn't even reach day 60. Let's do day 40. Takes a little bit to run. Nope, doesn't even reach day 40. So let's start at day 20 then. All right, so we're at day 21. And our x coordinates is, oh, it's a ton of them. Okay, because they're not unique. We have a lot of tiles. Something that I will optimize as well is I'm gonna make this unique, a unique set of, because we have a lot of tiles. We're gonna end up with repeating coordinates, and passing this into mathmin or mathmax is making our call stack size exceed whatever limits there are, because we're passing like 100,000, I think I saw 100,000 elements, and that's too much for our program. So I'm gonna make this a unique set of coordinates, because we only care about the unique values anyway. And a good way to do that is by saying new set, and then spreading out the set. Is that gonna work? I'm using a little trick here to pass the values to a set and then spread them out back to an array. And by passing them to a set, it's gonna make sure that it's unique, because sets can only have unique values. So yeah, that looks better now. We only have 47 coordinates. Good. So let's do that for this and this as well, for the Y and Z. All right, and let's run the program again. Did we fix our maximum call stack size issue? I think we did, but the program still takes a while to run. Let's see how long it takes. I'm fine with if it takes a minute or two, a couple of minutes. I'm fine with that. If it takes 10, 15 minutes, then it's probably best to optimize it so it runs faster. Still running. I could probably log the day, so then we know how it's doing. Let's do that. Let's log console log day and then run it. So 14, 15, 16. It's taking exponentially longer, which makes sense because we're expanding the X, Y, and Z boundaries, and we have 3 nested loops inside, so it takes exponentially longer, and we can see it's already going pretty slow around day 35, and I'm assuming the last days are going to be really slow. So I'm going to leave this running just for fun, and in the meanwhile I'm going to think about where I could optimize this. So the biggest drain, the biggest is, I think, are these nested loops. These nested loops is what takes up most of the time. And this is all fine here, I guess. So these nested, and then we have another loop here. We could, maybe it's this loop that takes a lot of time. Not sure. I wish there was a way to do a performance test on an operation inside a loop, so I know, like, for example, what I want to know now is this. Let's take this code block. I want to know how much time it takes to execute over the total amount of loops. Maybe I can do a console perf time, duplicate that, time ends, and then move this to the bottom. Okay, I'm gonna stop it because it's around 53 and it's running really slow. Right, so it does take a significant amount of time. This loop over here, we can see it increases to 200 milliseconds. That's not insignificant. Saying like an iteration takes about a second now, this takes up a quarter of that time. And the rest of the time I think is spent in here and up top. So, so I guess it would be better. It would be better if we had a copy. So taking the other approach, what I mentioned earlier, making a copy of this object of tiles to flip, making a copy of that, and doing the addition right here, so we don't have an additional loop after we've gone all through all the tiles. So I'm gonna copy this object over here, which is at the top. I guess tile flips, good. Current tile flips, and I need to copy it. How do I copy an object? I guess copy object JavaScript. I guess I can use from entries object assign. That'll work as well. All enumerable own props from one source to a target object. Okay, that will maybe work. Object assign. And what is it going to return? Assign all enumerable own properties from one or more source objects to a target object. Returns the target object. Okay, so we're going to start with an empty object, and I want to copy tile flips. And I want to we're going to use tile flips in here to read, all right, and to write we're only going to use current tile flips. Plus plus, like this. Oh wait, I need to actually read. So current tile flips. this tile plus plus. Yep. Okay, and then at the end, I can get rid of this now. At the end, the tile flips become current tile flips. So tile flips becomes current tile flips. Get rid of this as well. Wait, tile flips is a constant, so I cannot do that. Is a constant, so what I can do instead is maybe a new variable, current tile flips. I'm going to duplicate this and I'm going to say next tile flips. Okay, so we're going to have two copies, current tile flips and next tile flips, and we're going to modify next tile flips, and we're going to say next tile flips, we're going to say current tile flips is next tile flips, and then we're going to copy next tile flips, object assign so that the next time we modify next tile flips, it's on a different object, and then we're gonna have to read from current tile flips instead of tile flips. So everywhere here, I think this is the last occurrence. Oh no, at the end also as well. Right. Maybe, oh, what if I did this at the beginning? Or at the end? It's fine. Let's move this up top. All right. And here we need to not read from tile flips, but from what's our final state. It doesn't really matter. Let's see. Current tile flips. What makes most sense to do this? Copying, because I copied once here and also copied here at the end. And I think I can do that once here. I can move this here and it can make a copy. So we start with the current tile flip and we make a copy of that. And then we made a copy, and then we use that copy, and then we assign the copy to the current tile flips, and then we can get rid of this. And on the next iteration, we're going to make another copy to start fresh. Okay, that makes sense. And then I guess I can use current tile flips here to figure out the number of black tiles. Okay, let's see how fast the program runs this time, now that we got rid of that loop. First, let's fix a error, constant variable, true, this needs to be let. Ooh, much faster now. That's awesome. So that single loop took us a lot of time, which I didn't expect, because I expected the nested loops to take a lot of time. Or maybe I introduced a bug. So we are working with our example input here, and we have 552. I don't think that's the correct answer though. It should be 2208. Okay, so let's add a I'm gonna add this variable here just so I can debug it and see what the number of black tiles is after each iteration. So on the first iteration we start with 10, and then that's the first day. So on the second day we have 534 black tiles. That is definitely not correct. We are using our example input, yeah. Just this, right? Yeah. All right, so day 1 should be 15, day 2. And I guess we start at 0, day 0. Or day 1, after day 1, right? After day 1. So what I want to count, I want to count it here. I want to do this all at the end. Number of black tiles. Yep, I want to count this here. So therefore I'm going to add a breakpoint here before the incremented day. Run it again. Oh, let's remove this one. All right, so we're at the first day, day 1, and we have 534 black tiles. That is not correct. So somewhere we have a bug. Let's add another breakpoint in here before we flip a tile. Let's see what's going on. So our current tile is undefined, so it should be on 0. Let's run it again. Current tile is 0. The neighbors are also all 0. What's x? X is -4, y is -3, and z is -4. Well, that's interesting that we're starting with, Oh yeah, because it's the example input. Okay, that's fine. Yep. Okay, so x is, I thought this was wrong, but x is, y and z are all minuses. Good. Current tile is 0. Neighbors are, I guess, 0 as well. Number of black tiles is 0. Is black tile to be flipped false? False. This also false. So we don't flip any tiles. And then we go to the next iteration. I want to know I want to grab, if I go to tile flips here. So the origin tile, x0, y0, z0, this one is black. So let's go to that tile. I'm gonna add a conditional breakpoint here to be when x is 0 and y is 0. And z is 0. So then we have the origin tile. Let's see what happens to the origin tile. So we have our current tile is black, z, y, and x are 0. The neighbors of these tiles are these ones. Is that correct? Okay, so this is the east neighbor. The east neighbor is let me see. Origin tile east neighbor is what did we say? Is x plus 1 and y minus 1. X plus 1, y minus 1. So it's x1, y minus 1, which doesn't exist. So that's 0. That's good. The second neighbor is also 0, which is southeast. I think our neighbors are right. I don't think I need to check through them again. Maybe I can really quick. Southeast, we go southeast, axis stays the same. Z increments by 1, y decrements. That's correct. Southwest, x decrements, z increments, y stays the same. X increments, z decrements, increments, y stays the same. Just double checking this, that I get the neighbors correctly. Here z stays the same going west, but then we decrement x and we increment y. Decrement x, increment y. North west, we decrement z and increment y. Decrement z, increment y. And then northeast, we increment x and decrement z, increment x, decrement z. Yeah, I think the neighbors are right. So we have these neighbors, and so the number of black tiles is 1. That's correct. Is black tile to be flipped? Nope. Is white tile to be flipped? Also nope. Let's make sure that, I think our rule logic is pretty good. Let's make sure our rules are okay. So if the tile is black and has 0 or more than 2 black neighbors, then we flip it. So if the tile is black, which is this, and has 0 or more than 2, we flip it. And if the tile is white, which is this, and exactly 2 black tiles, is it? Exactly 2 black neighboring tiles, we also flip it. Otherwise it stays, otherwise it just stays the same. We don't flip it. What I'm also gonna do is something I forgot is exactly, here's our bug. We end up with another number of values because we could also have undefined tiles, in which case there should be 0. So in case when we want to flip a tile, we first instantiate to 0, assign it the 0 variable if it doesn't exist, and then we increment it. Kind of like what we did up top here. Because if you're going to increment an undefined value, you're going to get another number. Not sure if that was that was one of the bugs. I'm not sure if that's going to give us the solution, but let's try. So we don't need to log the days anymore. So on our first day, we have undefined. That's interesting, because current tile flips, right? And then I need to add a breakpoint there. $15. Okay, so that's correct. After day 1 we have 15 tiles. After day 2 we have 12 tiles. That's also correct. After day 3 we have 22 tiles, which is not correct. We should have 25. So we're still wrong somewhere. Let me make sure that I'm indeed copying the array. So next tile flips. We assigning it to the current one to be used in the next iteration. And then here we are copying it. And then we use the, oh wait, I see what's wrong. We use tile flips here instead of current tile flips. So tile flips should not be used anywhere inside. And current tile flips should be used, yep, everywhere here. Good, all right, so let's try it again. I'm gonna remove this breakpoint. So day 1, 15, day 2, 12, day 3, 25. Okay, 25, and then let's go a little bit more. 14, 23, 28, 14, 23, 28. Awesome. Let's, I'm gonna stop the debugger. I'm gonna run the program. And, oh wait, I think because we fixed the debug, we're back to our slow running program. No, but let me remove this because we don't need this anymore. And I'm gonna log the program, see how it goes every day. So it's definitely faster because remember we removed that loop that would like flip the tiles at the end. So it's definitely faster now. And it looks like, I mean, yeah, it's kind of slowing down around 70. I think that's all right. I think we can wait until it finishes. It's just 100. It won't take too long. So probably the most time intensive right now is I think either somewhere in here and the nested loops are taking a lot of time. So could probably optimize this in a way. I'm not immediately sure how, but if I get a correct answer with this program that runs I think in a minute or so, I'll be pretty satisfied. Yep, awesome. It took 1 minute and 14 seconds and we got 2208, which I believe is the right answer. Awesome. So then I'm going to run it with our input and hopefully it's not, oh yeah, that's what I figured. Because our input is much bigger, it's a bigger grid. It slows down much quicker than tile 70. It slows down around there, so it's going to take much longer to run. All right, so we might need to optimize it a little bit somewhere. I'm going to leave it running for now. But yeah, maybe maybe I can do some performance. Okay, let me log. So this is the copying. Console log copy. So no console time. I'm gonna log how long it takes to copy the copy of the object. And I'm also going to log how long it takes to get the coordinate boundaries. coordinate boundaries. Boundaries. And that ends there. Okay. Oh, we're 72. Okay, 73. Yeah. While I leave this program running, I'm gonna create a new terminal instance, and I'm gonna say, so we can. So let's see. The copy takes about a millisecond, but it doesn't really increase. The copy time stays the same. Oh, here it increased a little bit, but it's still significantly small, so I don't think we need to care about that. We don't have to optimize that. The calculating the coordinate boundaries, that's also relatively okay, 5 milliseconds. That's definitely not what takes up the bulk of the time, because here we can see around this iteration it takes about a second, and these two take about 15 milliseconds, so that's not something we should worry about. So I think here is where we need to start optimizing things. And how far are we with the program here? 86. We're getting there. 86. Here, and we're filtering. We're using a filter a lot of times because we are in a triple nested loop here. So we have to consider anything that happens here happens a bunch of times. Like, yeah, it goes up exponential. So anything that takes a small amount of time is going to add up to a lot of time. So here we are reading from an object. That should be quick. Here we are creating an array and we are reading from an object 6 times and creating an array. That should be quick. The filter should not be that quick though. So maybe perhaps instead of when we read an object, can we at the same time figure out if it's black or white tile? Maybe that's something we could optimize for. Well, this is a small, this is a small array, and doing a filter on a small array, some computation here, and then getting the length. Yeah, and then a couple of 2 conditionals here, and then incrementing. Incrementing might take a long time. Yeah. All right, so let's see, our program must have finished. Yep, it took 4 minutes, 44 seconds. I'm gonna see if it's the correct answer. I think it is. Yeah, it is. Right, so we finished day 42, both parts. Second part took a bit long. 4 minutes, almost 5 minutes. I don't see a way to optimize this straight away. We could perhaps let me get rid of this. We could perhaps, I don't know, maybe there's a trick to knowing the neighbors, to getting the neighbors instead of getting the neighbor. Yeah. Assignments, addition. Yeah. I'll have to do more performance tests here and see how long these take. But I'm happy with what we have so far. I think I'm gonna commit this and push this solution. I'm pretty happy with it. So let's say git lens, close. Let's git lens. Oh, right. So where's here? Let's add day 24. And let's add this one as well. And we can actually get rid of the example input. Right, so git status, git commit day 24 solved. Solved, yay. And I'm gonna push it to the repository. This is the repository where I store all the solutions for Advent of Code, starting from day 1, and day 24 should be in here as well. I linked it at the beginning of the stream in the chat, but I'm gonna link it again. This is where you'll be able to find my the solution for today's problem. And if you're watching this on YouTube, the link of to the repository is going to be in the description below. And yeah, I think I'm going to wrap it up for now. And I'll see you tomorrow for the last day of Advent of Code 25. We are at our final destination. Awesome. And if you're watching this on YouTube, just click to the next video. Thank you very much for watching and sticking around. Appreciate it. And I hope you have a nice day, and I'll see you tomorrow. Bye bye.